Hello, my name is 𝗦𝗽𝗲𝗀𝗏, and I'm joining from the DevRel team at Docker to talk about simplifying AI development, maximizing the power of local models, and MCPs. Specifically, we're going to talk about two new capabilities that we've added to the Docker toolchain, the Docker Model Runner, and then Docker MCP Catalog and Toolkit. Let's jump in first with the Docker Model Runner. As we've talked to the developers, one of the things that we've really come to understand, and we feel very strongly about ourselves, is that we want to enable developers to use the same processes and same tools, even with this new stack. This new stack has some new things to it, but many ways it's the same. Okay, we still want to be able to use containers. We still want to be able to use compose. We still want to use test containers for integration testing, but models, they bring an interesting wrinkle to it because they require GPUs, and running models with a GPU inside of containers is a tricky thing to do, especially during local development. So to solve that problem, we built the Docker Model Runner. And what the Docker Model Runner allows me to do is I can pull models directly from Docker Hub or any other container registry. We've created an OCI artifact specification to package up models and distribute them completely independent and decoupled from the inference engine itself. And then once those models are pulled, then I can run them completely locally on my machine. They don't run in containers. Again, they run natively on the machine. And what that does is it gives me full GPU access, allowing the models to run much more quickly. And the models are exposed through OpenAI API compatible endpoints. Now, how do I do this? What's it look like? We've developed a CLI, a set of commands that look very similar to what most developers already are working with. So I can do a Docker model pull and pull models, I can list models, and then I can even run prompts against them. And so to demo that really quickly, I can do Docker model pull, and I'll pull the 5.4 model. Again, I've got it cached locally, otherwise we'd just be sitting here watching it download. I can list models, and I can see I've got quite a few different models here, and then I can do a model run where I'm just going to ask it to give me some things that I should do in Seattle after Microsoft build. Now, this happened, I got the response very quickly because the model's already loaded. And if I ask it again, I'll see the responses very quickly. So you'll notice that the responses are quite snappy as well. Now, where do I get these models from? Again, I mentioned that they come from Docker Hub, and we have an entire catalog of models available on Hub. If I actually switch over to my browser, we can see that we've got some models coming from Hugging Face. We've got the Gemma models and Llama models and mixed bread models and the 𝗲 models and Mistral. So there's, again, a lot of different models that are available here. But what if you want to package and distribute your own models? Well, we're creating tooling to do that as well. The commands here are still preliminary. We're still finalizing some of this. And probably by the time you're watching this, there will be updated versions of this. But again, the idea here is that I can use very similar commands to Docker model package, specify the licenses, the GGUF of the model itself, and where I want to push this model. And this will package it up and automatically push it to my registry. And again, any OCI compatible and compliance registry, which most of them are these days, will be able to handle these artifacts. And so again, you can distribute these models in your own internal organization repositories, registries. And then if you're using tools, for example, Docker Business's registry access management tools, those that are part of our business plans, you can ensure that the models that your developers are pulling are only those coming from your trusted internal registries. So again, it allows you to treat your models much like your container images when it comes to security and registry access. Now, how do I actually access the models? How do I use it? So as I mentioned earlier, the models are exposed through an OpenAI compatible API. And I can access that from anything that's running natively on my host at localhost 12434. Now, this port isn't enabled by default. And if I switch over to Docker Desktop here and go into features and development and actually enable the model runner, then I can enable the host side TCP support, and that's what actually exposes that port. Once that port is exposed, then in my terminal, I can just make curl commands against that port, and I can send a set of messages to the model, This one's not streaming the response, so it takes just a little bit longer to get the response. But hello, how can I assist you today? And then I see all the other things that I would expect in that API response from the chat completions endpoint here. Okay. Now, if I'm running inside of a container, though, I can't just simply use localhost because localhost will resolve to the container. To solve this problem, we've made a special host name, model-runner.docker.internal, which will resolve to the inference engine. And again, since this is all OpenAI API compatible endpoints, any of the tooling that I'm using that may be used in OpenAI libraries, in this case, the OpenAI client directly, or LangChain, or again, anything else that interacts with these clients, all I have to do is swap out the base URL and everything else will still work. And in fact, I can actually do a demo of that real quick. If I switch over to VS Code, I've got a .NET application here that is using the OpenAI packages here, and I just create a chat client, and I'm going to send it a request of, in 300 parameters or less, what types of things should I be excited for at Microsoft Build, and it's going to stream the response and just output it here to the terminal. So I'll press the play button here, and we'll see this build, and it'll run, and I'll start to get the stream of info back here. And it's telling me that I should be excited for Azure advancements, innovative AI tools, updates to Microsoft 365, etc. Okay. And again, this is all using models that are running locally on my machine. Okay. But let's this is great. Now, how else does this fit into the rest of the Docker tooling? Well, this is what it might look like in Docker Compose. And what this is doing is leveraging new capabilities within Compose, a plugin architecture, where we could say this particular service is going to use a provider of type model, and here's options to pass to that provider. And now with this, when I do a Docker Compose up, it's not going to just spin up my app and database, but hey, my app depends on this model. So this model will be pulled and will be available for me to use before the app spins up. And in test containers, again, I can use the test containers framework to be able to do integration testing and ensure that I've got the model runner containers available for me to use as well. So with this, let's go ahead and I'm going to switch to a demo where we have an application that's taking product feedback comments that we received. Again, it's all just fictional product feedbacks. And some of these are very positive comments. Some of these are, it's helpful when it works, but I've noticed a few glitches. Again, we want to summarize these comments. We want to understand the sentiment. Where are people struggling with interacting with our product? And can we even use the LLM to generate responses back? Okay. The way that this is going to work is it actually does a couple different things. So the processing comments will categorize the comments, and I'm not going to go through all the code here, but it's going to use the LLM to do some sentiment analysis, and then it's going to cluster those comments, and by clustering, it's going to generate embeddings. And if you're not familiar with embeddings, it's basically taking the text and creating a vectorized numerical representation of the semantic meaning of that text. Okay, and it's many dimensions to it, and again, I won't try to explain it all, but basically with this vector, I could take two comments and do vector similarity between them to figure out are these two comments closely related to each other. And again, we can start to figure out some clustering from that. So this is going to do some clustering, and then we've got a responder where we're going to use the LLM to say, hey, here's some rules. Can you go and generate responses to the comments? And when it runs, afterwards, it'll give me this output. So here's the original comment. Here's the sentiment, some of the topics that were discovered from it, the response that we're going to generate. So you'll see in this one, it's thank you for your kind words, where other ones where it's maybe was a little bit more negative. Hey, thanks for your feedback and bringing these issues to our attention. We're sorry to hear you ran into the problems, etc. Now, when this runs, again, I can just run Docker Compose up because I have a Compose file that specifies my LLM model, in this case v4, and my embeddings model, and then my app is just going to use those models. So I can spin this up, run Docker Compose up. We'll see the sentiment analysis will run against these. And this will take a couple minutes, so I'm not going to run the whole thing right now. But again, we could see the responses from the last time that I ran that I just went through a moment ago. But again, it's all running using the same tooling that I'm already familiar with using as a developer. Okay, so I'll go ahead and stop this now. And we'll jump back to our slides and talk about MCP. Okay. So as we look at MCP, first off, it's one of the most hotly talked about topics right now. I want to take a second because not everybody actually understands what MCP actually is and what problems it's trying to solve. So I want to take a second and explain that real quick, and then some of the struggles of MCP, and then how we at Docker are looking to solve those problems. So when an application, so in case an application may be VS Code or Claude or Cursor or really anything that's going to be interacting with an LLM, when it sends the collection of messages, it can also send in that request, here's basically a collection of tools that the LLM can decide whether it needs to use or not. So for example, if I ask for the current time, well, the LLM is not going to be able to know the current time, but if I pass along a tool description to the LLM, it can say, well, yeah, I need to know the current time. Let me invoke that tool, and it will send a response back in which that response will say, hey, application, can you invoke this tool and then give me the output of that tool? Okay. And so tools can be used to add capabilities or execute workflows, get additional information, et cetera. It's actually, as an example of this, I'll switch over to the terminal here, and I'm going to ask for what is the current time in New York City, but I'm going to provide a tool description to say, here's how you can get the current time for a specified time zone. And what we'll see here is, again, I'm going to send this definition and the messages, and in the response back, the message, I don't get any text back, but the LLM says, hey, can you invoke this tool for me, this get current time? Now, the LLM doesn't know how I'm going to implement this. All it knows is here's the identifier of the tool that I want you to invoke and the parameters that it called. And then it's up to the tool to then figure out how to actually invoke that. Is it a local function call? Is it I'm going to delegate to some remote function call or make some remote API calls, whatever. Again, it's up to the app. So with tool calling here, what's quickly emerged is how do we package up and distribute reusable tools? And it really kind of plays into this remote function call. If for example, GitHub wanted to say, hey, here's a collection of tools to query repositories and pull requests or make new branches, et cetera, how can they package up their tools and allow me to hook it into the application here? And that's where MCP comes in. So MCP allows me to just connect this external set of tools and then delegate the execution of that to this MCP server, okay? And the way this gets configured is, and the configuration looks a little bit different per application, but for example, this particular configuration will say, hey, when this app starts up, I want to run a GitHub MCP server, and to do so, I'm going to use this npx command. This is coming from the Node ecosystem, and it's going to download and install the dependencies and everything to run this server GitHub tool. And now this MCP server will start up, it'll expose the tools, and again, my app can send the descriptions of those tools to the LLM, and I can delegate the execution to here, to this MCP server. Then this MCP server also needs a GitHub personal access token to be able to run. And here's another example using UVX, which is a part of the Python ecosystem. But what you're maybe starting to see is, well, what if I don't have npx installed? What if I don't have UVX installed? Wait, so I'm going to have to install this stuff just to be able to get access to all these different tools. And that's one of the problems that exists right now. Many of these MCP servers are being packaged and distributed, and it's up to these MCP clients to then launch these actual servers. But that, again, means that you need to have npx in all the different tools that are required to spin up these servers. Now, I shouldn't have to worry about this. I mean, at the end of the day, isn't that what containers solved? That I can just do a Docker run. I don't have to worry about what's in the box, just run the container. And so that's what the MCP catalog is providing. The MCP catalog, if I switch over to my browser, I can see a collection of MCP servers that have been containerized. And again, I don't have to know, is this Node, is this Python, is it Go, is it PHP, is it Java, I don't have to know how it's running. All I know is it's a container and I can just run it. This also gives me extra assurance because I know when the container's running, it can't access anything on the host file system or configuration. It can only access the things that I'm explicitly given it access to. Okay. Now, so what's that look like when I configure my application? Well, now instead of a npx command or UVX, now it's a Docker run. Okay, so in this case, I'm going to do a Docker run MCP time. But now again, if I've got Claude and VS Code and Cursor, whatnot, I've got now lots of containers for all these different services, and I start to get a web kind of like this where everything is launching their own containers, which is starting to be a lot of containers, a lot of resources to leverage. But again, also some of these need their own credentials and configuration. So how do I manage this centrally? And how do I do so securely so that I'm not just having these static files with the configuration, how to launch these servers with all these tokens in there, whether it's GitHub credentials or Slack credentials or Azure credentials, et cetera. Like, how do I do this the right way? And that's where the MCP toolkit comes in, which allows me to essentially manage the MCP servers that I want to use and then configure those servers with the API tokens, the database credentials, whatever else I might need to run that server. And then the MCP client is really just connecting to this toolkit, which is in many ways like an MCP gateway or proxy. And I can enable and disable servers here, and that the client, again, is just getting whatever is enabled. And it allows me to easily say, I want this set of tools available to all my AI applications, and I can manage it all centrally. Okay. Again, the MCP toolkit provides easy discovery, configuration, and launching of these containerized MCP servers. And so now in my VS Code configuration, I can just basically say, hey, connect to that gateway. All right. So with that, let's do a demo here, and I'm going to switch over to the Docker desktop, and we'll take a look at this. So again, I've got the list of all the available tools, and I'm going to just search for GitHub. And I'll see that there is a GitHub MCP server that I've already enabled. And if I open this up, I can see that there's a lot of tools that this MCP server provides. And I can specify configuration. In this case, it needs a personal access token. I've already entered that in here. And that's all I have to do. Okay, so now how do I actually now connect this to the clients? Well, for quite a few clients, I can just open this up and I can click configure and I'll write the configuration details that are needed. And you'll notice that VS Code isn't here right now. By the time you watch this recording, it probably will be in there. But for any others, I can just copy this command. And now let's actually go back to VS Code and let's add this MCP server. Okay, so I'm going to add an MCP server. I want to specify this command, and I'm going to call this just the Docker MCP toolkit. Okay. And I'm going to put this in user settings so it's available in all workspaces. Now that I've done that, I can see this here and I can click start. And now I can see that there are 32 tools that are available. Now, if I actually go back to Docker desktop, and let's turn off the GitHub MCP server now, and then go back to VS Code, you'll see now that there's only 2 tools that are available for me to use. Okay. And I'm going to go ahead and re-enable the GitHub MCP server, and we'll see now that the 30 tools are back. Now from here, I can open up Copilot and put this in agent mode. And again, I can see the 32 tools, and I can trim down this list if I want to, but I can now ask it questions like, tell me about the last PR that was merged into the Docker samples catalog service node repo. Okay. And so again, what's happening here is the description of tools are being sent to the LLM, and the response comes back and says, okay, I want to run this tool, and I can see the details about it and say, yeah, go ahead and run that. And it's going to send the response back to Copilot, which then will generate a response, and I'll get some details about it. And I can even ask it more of like, tell me about the files that were changed in that PR. and I'll see that now it's going to ask for pull request files. So again, it's using the MCP servers that are running locally on my machine using my own personal access token, and I can see details about this. Now, if I open up Claude or any of the other tools, I would get these same capabilities as well too. So with that, that's what Docker's bringing, and I thank you for joining us. If you're with us live in Seattle, feel free to stop by the booth and ask questions and get more demos as well too. If you're joining us remotely, feel free to check out the resources below. And we look forward to hearing from you and hearing your feedback as you try out these new tools. Thanks all.